Hello everyone. In this video we are going to talk about another problem that we got from 2013 Singapore Maths Olympiad. In this problem from number theory we have a1 plus a2 over 2 factorial plus a3 over 3 factorial up to an over n factorial is equal to 1 over 2013 to the power of 1000. We know each ai for I is equal to 1 to n is an integer, n is also an integer, and they are positive. We know ak for k is equal to 2 to n are less than k, and we want to find the minimum n that satisfies this equation. Note that we don't know the values that we have for a1, a2, a3 up to an. Before moving forward to talk about the solution, make sure that you pause the video to think about the problem. To solve this problem, let's start with an identity. For k and n as positive integers and n not less than k, we can write n factorial over k factorial as n times n minus 1 times n minus 2 up to k plus 1 and then times k factorial over k factorial. It's obvious that we can remove k factorial from top and bottom of this equation, and then we can show that n factorial over k factorial is an integer. Based on this, we are going to simplify the equation. First, let's multiply both sides of this equation by n factorial. If we do so, then on the right hand side, we are going to have n factorial times a1 plus n factorial times a2 over 2 factorial up to n factorial times an over n factorial. On the other hand, on the left hand side, we have n factorial over 2013 to the power of 1000. The right hand side of this equation is going to be an integer based on what we saw. On the other hand, these two are equal. As a result, the left hand side of this equation should also be an integer. So we need to have an n so that n factorial divided by 2013 to the power of 1000 will be an integer. Before further discussing about the solution, let's see what's special about n. Instead of multiplying both sides by n factorial, let's multiply both sides by n minus 1 factorial. If so, then we are going to have n minus 1 factorial over 2013 to the power of 1000 for the left hand side, and then n minus 1 factorial times a1 plus n minus 1 factorial times a2 over 2 factorial up to n minus 1 factorial times an over n factorial for the right hand side. In this case, we have integer values for all the terms except for two terms. On the right hand side and for the last term, if we remove n minus 1 factorial from top and bottom of the equation, then we have an over n. Remember, based on the assumption that we had in the problem, ak was less than k. So here an over n is not going to be an integer. So the right hand side of this equation is not going to be an integer. And then on the left hand side, we are not going to have an integer as well. So we need to find n such that n factorial over 2013 to the power of 1000 will be an integer, because we know that n minus 1 factorial over 2013 to the power of 1000 is not an integer. With that, we have an idea now that what we are looking for. We are looking for a number that n factorial over 2013 to the power of 1000 will be an integer. Remember, 2013 can be written as 61 times 3 times 11. If we simplify it, then we are going to have n factorial over 61 times 3 times 11 to the power of 1000 should be an integer. Let's simplify it a little bit more. 61 to the power of 1000 is actually 1000 times if we multiply 61 to itself. The same thing we can say about 3 and 11. So n factorial should have all these numbers to be able to have the whole expression as an integer. Now we are going to show that there is no need to have n factorial over this whole expression to be an integer. We just need to have n factorial over 61 to the power of 1000 be an integer. Since 61 is greater than 3 and also greater than 11 and is a prime number, if n factorial over 61 to the power of 1000 is an integer, then n factorial is going to have 3 to the power of 1000 as well, and it's going to have 11 to the power of 1000 as well. With that, we know that we just need to find a value for n such that n factorial over 61 to the power of 1000 will be an integer. Now let's simplify it a little bit further. Remember, 61 factorial is going to be 61 times 60 times 59 up to 1. We are going to have just one 61 in this expression. On the other hand, if we want to calculate 2 times 61 factorial, we can show that we are going to have two 61s in this expression. However, there is a trick here. If we increase the value that we have here and we reach to 61 times 61 factorial, you can see that it basically has 62 61 in it, because 61 times 61 already has two 61s. In total, we are going to have 61 plus 1 for the expression. If we follow the same approach, we can see that we are going to have 16 cases where we have two 61 in the expression. To find 16, we just need to calculate floor of 1000 over 61. 1000 was the power that we wanted to calculate, and 61 was the value that we wanted to have for factor. So based on what we saw, we can say n factorial is going to have 1061 in it. To find the value that is going to have 1061 in it for n factorial, we just need to calculate 1000 minus 16 times 61. To wrap up, let's summarize what we've done to solve this problem. We wanted to find the smallest n that we can have so that n factorial is going to satisfy this equation. First, we saw that if we multiply both sides by n factorial, we are going to have an integer. On the other hand, we saw that this is not going to be the case for n minus 1 factorial. After that, we calculated n factorial over 2013 to the power of 1000. We saw that we just need to find n factorial over factors of 2013. And the biggest factor that we had for 2013 was 61. So we wanted to find n factorial over 61 to the power of 1000 in a way that the answer will be an integer. To be able to solve that, we said we need to have at least 1061 in n factorial to be able to have an integer. We found the minimum n in a way that n factorial is going to have at least 1061 in it. Thanks for watching the video. If you would like to see more puzzles and math involved activities, please subscribe to the channel.